opposite we know is CB, you see me implemented here. 16 is the hypotenuse there. So 16 has become the hypotenuse, and therefore what we can do is we can implement all the values in. Theta is still 50. We rearrange it, multiply both sides by 16. You get 16 sine 50 equals CB. And CB comes out as 12.3 centimeters to 3 significant figures. So that sounds, again, relatively reasonable. Let's just see if there's a mechanism to have a check on that. One way we can do it is we could utilize Pythagoras. If it is true that our answers were 10.3 and 12.3 for this length and this length, then it perhaps should fit Pythagoras' theorem, which states that a squared, this length here, plus b squared, this length here, is equal to c squared, and we can go into details as to why that is in another time. For now, 12.3 squared plus 10.3 squared, if you square root it to find c, you do get around 16. So these values are correct that we've got here, and so we can utilize that as a little bit of a check. Now let's add more to this. Let's do the area. We can also find the area, not just of this triangle, but of both triangles. This length AB might be necessary if we want to find the area of both triangles. So let's consider what that is. If we know what CB was, which was that length here, if I double it, if I double CB, so I'm like, I don't just want CB, I want AB or BA. AB would be the more conventional way method. Then I would just take CB and I would multiply it by 2. Perhaps that's one way to look at it. And so in these circumstances, let's just take CB times 2. We'd have, in these circumstances, let's just take CB times 2. We'd have 16 sine 50 times 2. I would not take my 3 significant figure answer because it's been simplified way too much. It's almost more of an estimate at that point with only 3 significant figures. Hence, we'd have 16 sine 50 times 2, wherein I'm keeping the detail by using the trigonometric form, and I'd be able to find that length. Now, let's say I wanted to find the area of the whole thing, OAB. So this is what I'm now looking for. Our new objective is to find this area OAB. So what have we done? We've talked about how the area of a full circle is pi r squared. The area of a sector is pi r squared times what you want divided by the whole. For example, if we want the area of a sector of 30 degrees, we do pi r squared times 30 divided by 360. We then decided to take circumstances where we not just looked at the sector, so this would be the sector around here. We wanted to find out, well, if I draw a line from A to B, what other shapes manifest, and they are triangles. So we did a bit of a recap of such things as being able to find the length OC and CB, and we did trigonometry to do that, like so. And then finally, we were like, okay, right, we seem to have legitimate answers for this length and this length. We can double up and find AB, and then from there, why not get the area? Why not get the area of OAB? And so what we could do is we could